Welcome to the lecture 4 Engineering Mathematics for GATE and Engineering Services. Today we will study Unitary Matrix, Hermitian Matrix, skew Hermitian Matrix, periodic matrix, Nilpotent matrix and involutory matrices with their some important properties. Lecture 1 और lecture 2 में हमने इंट्रोडक्शन टू मैट्रिसेस में मैट्रिक्स का डेफिनेशन, उसके टाइप्स, डिटरमिनेंट, एडजॉइंट मैट्रिक्स, इनवर्स मैट्रिक्स, सिंगुलर मैट्रिक्स, नॉन सिंगुलर मैट्रिक्स। लेक्चर 2 में हमने सिमेट्रिक मैट्रिक्स, स्क्यू सिमेट्रिक मैट्रिक्स, ऑर्थोगोनल मैट्रिक्स को पढ़ा और उनकी प्रॉपर्टीज को समझा। लेक्चर 3 में हमने लेक्चर 1 और लेक्चर 2 में जो थ्योरी पढ़ी उस पर बेस्ड कुछ इंपॉर्टेंट और कंसेप्चुअल क्वेश्चन सॉल्व किए। लेक्चर 4 में आज हम कॉम्प्लेक्स मैट्रिसेस और कुछ अदर टाइप की मैट्रिसेस को भी पढ़ेंगे। सो अब लेक्चर 2 को कंटिन्यू मैं करना चाहूंगा। व्हाट इज द ट्रांजुगेट और ट्रांसपोज कॉन्जुगेट मैट्रिक्स। लेक्चर 2 में मैंने इसको डिस्कस किया था, इसकी प्रॉपर्टी को फिर से एक बार इसकी डेफिनेशन को रिकॉल कर लेते हैं। तो लेट A is equal to Aij is any rectangle matrix and suppose entries are coming from complex number, means entries are in the form of x plus iota y, then conjugate or transpose conjugate matrix A theta is defined as A conjugate transpose or A transpose conjugate matrix। आप कोई भी ऑपरेशन पहले अप्लाई कर सकते हैं। फॉर एग्जाम्पल, if we take a matrix A 1 plus I 2 0 minus I, then A conjugate will be 1 minus I 2 0 plus I. A conjugate transpose will be 1 minus I 2 0 iota, and this will be conjugate matrix A theta. So this is the example of conjugate matrix, and the properties of this matrix, important properties of this matrix I have already discussed in lecture 2. Now, what is the unitary matrix? Another important matrix. Let A is any square matrices, square matrix, and entries are coming from complex number, means some numbers can have non-zero imaginary parts also. Then A is said to be unitary matrix if and only if A into A conjugate is equal to identity and the matrix A is also commutative with respect to multiplication with conjugate matrix A theta. So A theta equals to identity equals to A theta A. अगर इसी मैट्रिक्स की एंट्रीज रियल हो जाएं तो यूनिटरी मैट्रिक्स विल कंसाइड विथ ऑर्थोगोनल मैट्रिक्स। देयर इज a basic difference between orthogonal and unitary matrix is entries are coming from real and complex respectively. In the orthogonal matrix, entries are coming from real numbers, although in the unitary matrix, entries are coming from complex number. Let us one example. A is equal to 1 upon root 3 1 1 plus I, 1 minus I minus 1. Verify this is unitary matrix or not. So you have to just verify that AA theta equal to identity equal to A theta A. Properties of orthogonal matrix. First, let A is let A is an unitary matrix then A transpose and A inverse. A inverse is also unitary matrix. Is also unitary matrix. Second property, let A and B are two unitary matrices of same order then AB and BA are also unitary matrices of same order. Third, unitary matrices unitary matrix coincide with orthogonal matrix if its entries means unitary matrix entries are real numbers. So these are some important properties of unitary matrix, and this is the definition of unitary matrix. Next matrix is Hermitian matrix. A square matrix A is said to be Hermitian matrix if matrix A is equal to its conjugate matrix. It means entries are coming from complex space. We have one example also. You can verify that A is equal to 1, 5, 1 minus I, 1 plus I is a Hermitian matrix. You simply check it, find its conjugate, and then take the transpose. So A conjugate will be 1, 1 plus I, 1 minus I, 5, and A conjugate transpose will be 1, 1 plus I, 1 minus I, 5. So A theta equal to A here. This is A theta. Now the properties of Hermitian matrices. First, in Hermitian matrix, diagonal entries are real numbers. How? Let A equal to Aij is any Hermitian matrix, then A theta will be equal to A. And what is A theta? A theta is A conjugate transpose. So if we take conjugate, then it will be Aij. It will be Aij conjugate, and if you take transpose, it will become Aji. Order will be remain same because we are dealing with square matrix. So A conjugate will be Aij conjugate. If you take transpose, then row will be changed with columns. So A theta will be Aji conjugate. Now put the value in the equation number 1. It will be Aji conjugate is equal to Aij. And I told you in my lecture 1, for diagonal entries I equal to j. So Ai conjugate equal to Ai. And you know that for any complex number, if the conjugate of complex number is equal to that number, it means, or you can take from this, it means the number is purely real, because it's the transpose, its conjugate is equal to that number only. I told you, if x is any real number, then its conjugate will be equal to itself only. It means here Aii is real number. Then only its conjugate will be equals to it. So it means Aii belongs to real number for every I equal to 1, 2, 3. It means every element of diagonal, principal diagonal, will be real number. In the case of Hermitian matrix. Property 2. If A is Hermitian matrix, then A plus A theta is also Hermitian matrix. One thing I want to clear you, if it will become symmetric if entries are real. Only difference is in the symmetric matrix, entries are coming from real numbers. In the Hermitian matrix, entries are coming from complex. Property 3. If A is here any square matrix, then the correction, if A is any square matrix, then A plus A theta is always Hermitian matrix. Is always Hermitian matrix. If A is any square matrix, then A theta and A theta A will be also Hermitian matrices. Hermitian matrices. Property 4. If A is Hermitian matrix, then A conjugate is also Hermitian matrix. And property 5 is, if A is Hermitian matrix, then A to the power n belongs to any natural number, is also Hermitian matrix. Next property, if A and B are two Hermitian matrices of same order, then any scalar multiple lambda 1 A plus minus lambda 2 B will be also Hermitian matrix. Next property, if A and B are two Hermitian matrices of same order, then AB is also Hermitian matrix, provided A and B are commutative with respect to multiplication. So these are some properties of Hermitian matrix. Next is skew Hermitian matrix. So what is the definition? A square matrix A is said to be skew Hermitian matrix if A theta equals to minus A. Means if we can take outside minus sign in the conjugate matrix, a transpose conjugate matrix, then matrix will be skew Hermitian matrix. A skew Hermitian matrix has some very important properties. So let's see the properties of skew Hermitian matrix. First, diagonal entries are purely imaginary or zero. Purely imaginary means there is no real part. No real part. How? A theta equals to minus A. This is the definition of skew Hermitian matrix. And A theta can be written as AJI conjugate, and A can be written as minus AIJ, because A is equal to AIJ and it is a square matrix of order n cross n. Then AJI conjugate plus AIJ equal to 0. For diagonal entries, I will be equal to J. It means it will be AII conjugate plus AII equal to 0. Let AII in the form of x plus IY, then AII conjugate will be x minus IY. So if we add AII plus AII conjugate, it will be 2x. On adding, it will be 2x. It means 2 times real part of AII. So this is equal to 2 times real part of AII, because AII are complex entries here. It means real part is 0. Real part of ai is 0 for every I. Therefore, diagonal entries will be purely imaginary or 0. 0 if imaginary part is also 0. Real part is already 0. If imaginary part is 0, then both parts are 0. So ultimately entry will be 0. So there are only two possibilities. Diagonal entry will be 0 or diagonal entry will be purely imaginary number. Next property. Property 2. Let A is skew Hermitian matrix. Then A conjugate is also skew Hermitian matrix. 3. Let A is any square matrix. Then A theta, comma A theta A theta, comma A theta A, and A minus A theta will be also skew Hermitian matrices. Will be also skew Hermitian matrices. No. This property is not true for these two matrices. It will be true for only Hermitian matrix. Why? Check कर लेते हैं. This is a mistake here. Check. A theta. Take the conjugate. It will be A theta conjugate into A. So A theta. So it will be A into A theta. It means conjugate is equal to that matrix only. If we consider it A, then A theta equal to A1 theta equal to A1. So A theta is Hermitian matrix. So don't be confused. If A is any square matrix, then A theta and A theta A both will be Hermitian matrix, not skew Hermitian matrix. But A minus A theta will be skew Hermitian matrix. How we can check this? Check A minus A theta. Let it is equal to A1. Then A1 theta will be A minus A theta conjugate. It will be A conjugate minus A theta conjugate. It will be A conjugate minus A. If we take minus sign outside, it will be A minus A theta. It will be minus A1. So A minus A theta is skew Hermitian matrix. Skew Hermitian matrix. Next property. Let A and B are two skew Hermitian matrices of same order. Then first, scalar multiple lambda 1a plus minus lambda 2 will be also skew Hermitian. Second, AB minus BA will be also skew Hermitian matrices. So these are some important properties of skew Hermitian matrix. Next is idempotent matrix. Any square matrix A is said to be idempotent matrix if A square equal to A. If A square equal to A. So this is the definition of idempotent matrix, and we have one very important property. If we take the determinant both the side, it will be determinant of A, and determinant of A to the power n equal to determinant of A to the power n. So it will be determinant of A square equal to determinant of A. Determinant we can take outside, determinant A, it will be -1 equal to 0. So there are only two possibilities, determinant will be 0 or determinant will be 1. So for any idempotent matrix, determinant is only 0 or 1. So if the options are given like this, check which matrix is idempotent matrix, and by calculating the determinant sometime, you can also get the correct option. Next is involutory matrix. A square matrix. A square matrix. A is said to be involutory matrix if A square equal to identity matrix. If A square equal to identity matrix. One trivial example is identity matrix is always involutory. Identity matrix is always involutory because I square equal to I. One property, if we take the determinant both the side, it will be determinant of A square equal to 1. So determinant will be plus minus 1. And I have already told you the determinant of orthogonal matrix is also plus minus 1. So by seeing the value of determinant, you cannot judge the type of matrix. But the converse is true. If the involutory matrix, determinant will be plus 1 or minus 1. If the matrix is orthogonal, determinant will be plus 1 or minus 1. But if the determinant is 1 given, you cannot say it is a unitary matrix or it is a orthogonal matrix. Next, periodic matrix. A matrix A is said to be periodic matrix if A to the power n plus 1 equal to A. If after some powers of A, you will get again A, then it is called periodic matrix. Rn is here, n is any positive integer. And n is called period of the matrix. N is called the period of the matrix. If n equal to 1, then A square equal to A. So it is a idempotent matrix. Means idempotent matrix is a type of periodic matrix with period 1. एक बात और आप यहाँ पर ध्यान दीजिए कि यहाँ पर if A is square matrix, then only we can judge this. Nilpotent matrix. A matrix A is said to be nilpotent matrix if for any least positive integer k, it is a null matrix. It is a null matrix. K is here least positive integer. Least positive integer means what I want to say. Suppose a cube is null matrix. Then a to the power 4, a to the power 5, all the powers will be null matrix. Then the what will be the index? K is called index of the null matrix. Index of null matrix. So here we can see that k equal to 3, 4, 5, but the least value is 3. So 3 will be the index of null matrix. 3 will be the index of null matrix. One important property is, if you take the determinant of in nilpotent matrix, it will be determinant of a to the power k is equal to 0, and k is any positive number, positive integer, so determinant a equal to 0. So for any nilpotent matrix, determinant will be always 0. So these are some properties and some important types of matrices also. In the lecture 5, we will discuss some important problems based on determinants and some previous year question based on gate and engineering services. Thank you.